Hello, hi everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem, max area of island. So this problem is very similar to the problem where we find how many islands are there in a given grid. Basically what is an island? It's a connected group of ones which are four directionally connected, and we are given a matrix of dimensions m cross n. It's a binary matrix, contains 0 and 1s named grid, and the portion which contains 1 is the island and the portion which contains 0 is water. What do we have to do is we want to find the largest area portion in this given grid, right? And we have to return that maximum area of an island in the grid. If there is no island, then we return 0 in that case, right? So let's better understand it using an example. So here we have an example. We have a large grid and we have a lot of islands here. The first one is this one. The first one contains only one, so its size is 1. The second contains 4 ones connected to each other, so the size is 4. The area has 4 units. Then we have this area which again has 4 ones. Then we have this area which has 5 ones. Then we have this area which has 6 ones. Finally we have this area which has 5 ones. So the maximum area is for these ones which has 6 ones, right? So the answer for this test case would be 6. So let's just see how we can solve this problem. The solution is very similar. All we have to do is just use the DFS approach. So let's take an example. Let's understand it using an example. So let's take a grid. Okay, so in this grid we have 1, 2, 3, 4. We have 5 rows and 6 columns, right? And now let's create the islands here. Let's create the islands. One, 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 zero, zero. Okay, so let's see how many islands are there. The first one is this one, right? The island containing 4 ones. So the size is 4. The second one is this one, the island containing 2 ones. The third one is this one, the island containing 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. So the max of these 3 is 8. So the answer that we have is 8. That's what we have to find for every matrix. Now, how are we going to solve this problem? The answer is use DFS. Okay, so we use DFS for this matrix. Let's start from the very first cell. So let's start the DFS for 0, 0, and we can see that we have started DFS from this cell and will only visit those adjacent cells which contains 1 and which are unvisited, right? So this initial cell is unvisited, so we mark it as visited. And let's also count the number of ones as well. So the number of ones is 1. Now this will call itself recursively for the neighbor cell which is unvisited and which contains 1. And these cells are this one and this one. So let's call the same function for this cell, that is for 0, 1. And let's add 1 here for this cell, right? Now let's see the neighboring cells for this cell. The neighboring cells of cell 0, 1 are the cell 0, 2, the cell 0, the cell 1, 1, and the cell 0, 0. We can see that cell 0, 0 is already visited. Cell 0, 2 do not contain 1, so we can't visit it. Cell 1, 1 is the ideal neighboring cell which we can visit. So let's move to this cell. Okay, now let's move to this cell DFS 1, 1, and let's add 1 more here. Now from this cell, let's see the neighboring cells which are unvisited and which contains 1. So let's see this cell 1, 0, the cell 1, 2, the cell 2, 1. Out of these three cells, which are neighboring cells and are unvisited, we can see that this is the only cell which contains 1 and which is unvisited. So we move to this cell that is at 1 0. So we move to this cell DFS 1 0 and we add 1 here. So this becomes 4. Now we can see that for this cell we do not have any neighboring cell which contains 1 and which is unvisited, because all of the valid neighboring cells containing 1 are visited. This is visited, this is visited. So that's all. We can't recursively call the DFS function from here for any of the neighboring cells which is unvisited. So we move back to the cell 1 1, then we move back to 0 1, then we move back to 0 0, and finally we move back to the calling function, which is the main function. So this is basically the call stack. This is call stack that we can see here. Fine. So we get 4 as the size of this island, and these 4 cells are marked as visited. So we use another matrix of the same dimensions named visited matrix to just mark the cells visited. So if a cell is visited, we mark it as true, and if it is not visited, we mark it as false. Now let's move to the next unvisited cell, which is 0 2, this one, right? So we start DFS from this cell now. So we start DFS from this cell, which is, can we start DFS from this cell? Let's ask first. No, we cannot. We can't start DFS from this cell because this do not contain land. We'll just start the DFS from the cell which contains land, and that DFS function will recursively visit all of the neighboring cells containing land, right? So the next cell for which we'll call the DFS function will be this one, that is cell at 0 5. So let's call this function 0 5, and we can see the number of islands will be same as the number of times we are calling the DFS function. Till now we have called DFS function once, so we have encountered with 1 island till now. So now from this unvisited cell we mark it as visited. Now from this cell we move to the cell which is DFS 1 5, this cell, because this is the only unvisited cell containing 1. Okay, and let's count it. Let's count 1 plus 1. So 1 for this, 1 for this. So we have 2 as my answer. Now from this cell I cannot move to any of the adjacent cell. I can't move to this cell, I can't move to this cell. Okay, now let's move back to the calling function. So this we have computed the answer to be 2. Now move back to this this DFS function called 0 5, and then also pop this out. Okay, so both of these cells are visited, and the size of this island is 2. So we had 4 initially, now we have 2. We have 2 sizes till now. Let's move to the next unvisited cell containing 1. So let's move to the cell 2 0. So let's move to 2 0. This is unvisited. Let's move to 2 1. This is unvisited. Let's move to 2 3. This is also unvisited and it contains 1. So let's start DFS from this cell. Let's start DFS from 2 3. Okay, start DFS from here. And now let's mark it as visited and let's count it as 1. So let's recursively call the same function for the neighboring cell which contains 1 and which is unvisited. Let's call the same function for 2 4. Let's call for this neighboring cell. So let's count 1. Now for this the neighboring cells are 2 5, the neighboring cell is 3 4, and the neighboring cell is 2 3. So out of these 3 cells we can see that the cell 2 5 cannot be visited because it contains 0. The cell 3 4 can be visited, this cell. So we recursively call the DFS function for that cell, that is cell 3 4, and count one more cell. From this cell I can move to cell 3 5, I can move to cell 4 4, I can move to cell 3 3. So let's move to cell 3 3. So DFS 3 3, this one, and also count it as 1. Okay, so we have moved we have traversed these 4 cells, that is 2 3 2 4 3 3 3 4. Okay, now from this cell 3 3 I will move to cell 4 3. So let's move to cell 4 3, this one, and let's count one more. From this cell 4 3 I can move to cell 4 2 because this is the unvisited cell containing 1. So let's move to cell 4 2 and let's mark it as visited. So let's move to cell 4 1, DFS 4 1, and count it as 1. Let's move to cell 4 0 and count it as 1. Okay, and from this cell which is 4 0 I cannot move to any of the neighboring cells which contains 1 because we do not have any cell remaining which contains 1. So we can see that 1 plus 1 2 plus 1 3 plus 1 4 plus 1 5 6 7 8. So the size of this island is 8, and we are done. Let's move to the next cell which is unvisited and contains 1. We do not find any such cell. All of the cells which contains 1 has been visited. Okay, all of these calls will be popped out, and we have these 3 answers. All we have to do is to take this the maximum of these 3 cells while we are performing the DFS. We have called the DFS function 3 times. That means we have 3 islands, and for every DFS function call we computed the size of the islands, out of which I will keep updating the sizes using a like temporary variable, and the maximum size that I will get will be 8, and the answer will be 8. That is my answer. Okay, so that's all for this. This is a solution for this problem. Uh, you may have studied like the number of islands before, and the solution is very similar. तो बस इतना ही. Let's move to the code implementation part. So this is my max area of island. Let's first calculate the dimensions. N is equals to grid dot size. M is equals to grid 0 dot size. N are the number of rows, M are the number of columns. So let's create a visited array. So let's create a visited array which will be of dimensions n cross n. तो boolean array बनाएंगे. N vector m false Okay, so now let's iterate over all of the cells of the grid, right? तो शुरू करते हैं iterate करना. So let's first declare an answer variable जिसमें final answer store होगा. Answer is equals to 0, and so traversing every cell, when we find a cell which is unvisited, so कोई ऐसा cell जिसमें false है, that means this is unvisited, or this cell must contain an island. Okay, like इस cell में 1 होना चाहिए, is equals to 1, and so we'll recursively call this DFS function. We'll call this DFS function for this cell, right? For the cell I and j, ठीक है, and n m are the sizes of this matrix. Pass the visited array as well, और क्या pass करना है? हाँ, grid. Pass the grid as well because these components will be used there while we will be implementing this ये जो DFS function है. So void DFS एक ग्लोबल वेरिएबल डिक्लेयर कर लेते हैं जिससे बार बार इसको यहाँ पे ज़ीरो इनिशियलाइज करेंगे, काउंट ज़ीरो, और इस फंक्शन में इस काउंट को अपडेट कर देंगे. ठीक है. फाइनली जब हम वापस आएंगे तो हम इस आंसर वेरिएबल को इस काउंट से अपडेट करते रहेंगे जिससे कि मैक्सिमम काउंट इस आंसर में स्टोर हो जाए, विच विल रिटर्न फ्रॉम द एंड ऑफ दिस फंक्शन. ठीक है. सो शुरू करते हैं. लेट्स स्टार्ट DFS int node, and here we will have not node, I, then j, then row, then column. ठीक है. फिफ्थ आर्ग्यूमेंट इज द विजिटेड एरे. ठीक है. विजिटेड एरे वेक्टर bool visited. सिक्स्थ आर्ग्यूमेंट है ग्रिड. ओके, एंड दैट्स ऑल. इस करंट सेल को विजिट करो, ट्रू. नाउ मूव टू ऑल ऑफ द फोर डायरेक्शंस, मतलब एडजेसेंट सेल्स पे मूव करो. फ्रॉम लाइक लेफ्ट सेल, द सेल बिलो द करंट सेल, जो सेल उसके लेफ्ट में है, जो सेल उसके ऊपर है. ठीक है. let's mark it as visited. the current cell which is ij, let's mark it as true. let's increment the count here. अभी फोर डायरेक्शंस में मूव करेंगे. 0 लेस देन 4 प्लस प्लस. let's find the new क्या, let's find the new row. it would be I plus dri. let's find the new column which would be I plus dri plus 1. so let's check if this new row and new column constitutes a valid cell. so if this new row, if this is within the boundaries ny is greater than equals to 0 and nx is less than n and ny is less than m, और ये विजिटेड नहीं है. ठीक है. इट इज़ नॉट विजिटेड एंड इसमें 1 है. इसमें मेरे पास 1 है, राइट. so let's call the DFS function recursively. for this new row and new column, pass the visited array grid, and that's all. also count. okay, count यहाँ कर लिया. ठीक है. fine. so I think this should be fine. let's try to run this code if it works. n is not known. okay, we do not know n, we know r and we know c. कहाँ प्रॉब्लम आ रही है यार. it's not I. let's iterate it using k, right. okay, so we increment the count by 1. so let's Let's iterate over the adjacent neighbors with k is equals to 0, k less than 4, k plus plus. Let's calculate the new row, which would be, I plus d r k, new column, which would be I plus drk plus 1. So let's check if this is greater than equals to 0, ny is greater than equals to 0, and nx is less than n, and ny is less than m, and let's say if it is visited, nx ny is visited. If it is visited, if it is not visited, and this contains this nx, this contains 1. Let's call the DFS function for this new node, which is for this new cell nx ny, pass the rc visitor array grid. ठीक है, and okay, count होगा increment. That's all I think we have to do. nx should be less than r, ny should be less than c. ठीक है, and I think that's all. Here it's not I, it's k, okay, it's I and it's j, right? So let's run it. Okay, it got accepted. Let's submit it. Okay, got submitted. So that's all for this problem. It was a standard problem, and all we have to do is just perform DFS. तो easy था. Let's discuss the time complexity. Time complexity discuss करते हैं इसकी. Time complexity same होगी जो DFS की होती है. We know the time complexity for DFS is big of n plus e, and for like we are performing DFS in मतलब मैट्रिक्स में कर रहे हैं तो n इंटू एम हो जाएगा, where n इंटू एम आर द डायमेंशंस ऑफ दैट मैट्रिक्स. स्पेस कम्प्लेक्सिटी भी सेम ही होगी, बिग ऑफ n इंटू एम, because of the boolean array you can say we are using. And auxiliary space जो यूज़ होगी वो भी बिग ऑफ n इंटू एम होगी. Sorry, not the auxiliary, stack space. क्यों? Because you can see that we are recursively calling the functions. We are recursively calling the functions, the DFS function for all of the cells. So in the worst case हमारे पास ऐसा हो सकता है कि मैट्रिक्स में सभी वंस हो, 1 1 1 1 1 लाइक दिस. तो DFS फंक्शन यहाँ से शुरू किया, वो सभी के लिए कॉल होगा रिकर्सिवली. ठीक है, तो उस केस में दैट इज़ द वर्स्ट केस. सो दैट्स वाई उस केस में हमारे पास कॉल स्टैक में सारे के सारे फंक्शंस होंगे एट द सेम टाइम सभी सेल्स के लिए. सो दैट्स वाई आई एम सेइंग कि जो वर्स्ट केस कम्प्लेक्सिटी है स्टैक स्पेस जो है, दैट वुड बी बिग ऑफ n into m. Fine. So I hope you got the idea how we solve this problem.